All right, so today is Friday, May 1st, and we're going to be working on sample proportions and also type 1 and type 2 errors. This will be the last of the discussions on proportions. There will be a Stat Saturday tomorrow. I hope you'll be there. Again, this will be tomorrow. Stat Saturday will be on means and proportions, and I think it's really important. Obviously, otherwise we wouldn't take the time to do them. Before you join us tomorrow, it would be great if you had opportunity to do Stats Medic Units 6 and 7. And this is prior to April 25th. Obviously, that's wrong. Prior to May 2nd. But anyway, if you can get that done, that would be great. I look forward to seeing you there. Next week, when we start our distance learning, on the Zoom meetings, I'm going to hope to have some problems that just quick review of things that I think are important. So they're going to be randomly selected things. It's not going to be subject specific, but they're going to be things that I think have high likelihood of being selected. So that will be next week's Zoom meetings. Oh, one other thing is there will be a change to your homework beginning next week, and I hope to have that out to you guys Monday. You will have some FRQ assignments. The FRQs will be backed up with videos, so that if you get stuck, you should be able to watch the video and know exactly how to work the problem. Again, this is just an opportunity for you to teach, for us to teach and for you to learn a little bit and get some practice in for the exam. And you will upload the documents either by taking a picture and emailing that to us. So that's the way that will work. Okay, so problem 9 from 2016, question 5. Polling agencies showed the following two statements to a random sample of 1,048 adults in the United States. And the question was environmental statement. Protection of the environment should be given priority over economic growth. Economy statement, economic growth should be given priority over protection of the environment. So the order in which the statements were shown was randomly selected for each person in the sample. After reading the statements, each person was asked to choose a statement that was most consistent with his or her opinion. The results are shown in the table. By the way, the fact that they randomly selected the order, I think, was important. We saw that on Wednesday's lesson when which show do you prefer? Seinfeld or Friends, and they swapped the order and the percentages changed. So kind of important to be randomized. So the results are shown in the table. And we have 58% chose the environment, 37% the economy, and 5% said no preference. I'd like to go back up to the top real quickly and say, hey, you know what? Because I forgot to make this notification. They said it was a random sample. Now that's kind of a cute thing to say because it implies that it's only one random sample. And so we have 3 answer choices, but this is a single random sample, and that makes sense. It's like, okay, here's the one question on the test, and you have a choice of A, B, or C. That's fine. So it says, assume the conditions for inference were met, and we all said, yay. Construct and interpret a 95% confidence interval for the proportion of all adults in the U.S. who would have chosen the economy statement. Well, since they told me that the conditions are met, I don't need to address them. But I do need to still define my variable of interest, and my variable interest is P or P naught, and it equals the true population proportion of adults who would have chosen the economy statement, because that's what we were interested in. Now the question is, and I'm just going to bring this up real quickly, when you run one of these tests, you need to be sitting with a yes-no situation. And here we have 3 answer choices, but we still have a yes-no. Either they chose the economy, either they chose the economy, or they didn't choose the economy. So 37% chose the economy, and 58 plus 5 or 63% didn't choose the economy. So it still satisfies the yes-no condition. All right, so our formula, p hat plus or minus z star. And then we have p hat, q hat. Make sure if you use q hat, you define it. Otherwise, you need to put the 1 minus p. They didn't tell us, and so we know p hat equals x over n. So p hat in this case is 0.37. And 0.37 equals x over 1,048. And you're like, well, why did you do that? Well, the reason I did that is because if I'm going to use the calculator, I have to know what both x and n are. Well, as it turns out, I get a decimal answer. This is really, really critical. You have, in these cases, when you're working with proportion, x and n must be whole numbers. I highly recommend at this point that you would round to the nearest value, just the way you were taught back in elementary school. So in this case, I'd round to 388. If you truncated, that's going to be fine too, but you're going to be happier. Overall, we'd be happier if you didn't. So I rounded up because that would be what I learned in elementary school. So now I'm going to go ahead and run this test. Stat test, 1 proportion z test. Oops, excuse me, I'm not running a z-test, I'm running a confidence interval. Stats test, letter A, I believe. 1 proportion z interval. And we had an x value that I calculated off to the side of 388. We had a 1,048, a confidence level of 0.95, and so then I obtained my interval. Now, please note that I plugged in all these values, but what I still haven't solved for is the 1.96. So I'm going to go back and solve for that 1.96 just as a reminder. So second vars, inverse norm, 1 minus 0.95 divided by 2. And that's where my 1.96 came from. And the 1.96 is the number of standard deviations. All right. So we always have to have our conclusion. Our conclusion is we are 99% confident. Excuse me. No, we aren't. We are 95% confident that the true population proportion of adults who would have chosen the economy statement lies within this interval. All right, that would have given you full credit on part A. Technically, you didn't need to show what X and N were, but if for the calculator purposes, you needed to know how to do that. Okay, so one of the conditions for inference that was met is that the number who chose the economy statement and the number who did not choose the economy statement are both greater than 10. Explain why it's necessary to satisfy this condition. Now, they didn't ask me to say why it's important. They asked me to explain, they didn't ask me to explain how I calculated. They explained why it was important or necessary to do so. Well, it's necessary for this condition to be met so the sampling distribution of p hat will be large enough to approximate the normal distribution. So basically, we're doing this to make sure we have a large enough sample for it to be approximately normal. These are good words to use. Sampling distribution of p hat. Had we been working with sample means and say, why does n need to be greater than 30? It would have been the same thing, except instead of the sampling distribution of p hat, we would have said the sampling distribution of x bar. So if we've been working with sample means, we would have just changed this, and this would need to be, instead of greater than NP and NQ having to be greater than 10, our sample size would have had to have been greater than a 30. So a suggestion was made to use a 2-sample Z interval for a difference between 2 proportions. All right, to investigate whether the difference between adults in the United States who would have chosen environment and those who have chosen economy statements is significantly different. They said, hey, we have 58% here, we have 37% here. Let's run a hypothesis test to see if they're different. And Is a two sample Z interval for a difference between proportions appropriate procedure? Justify your answer. And the answer is no, it's not. It kind of says it in the title. It says a two sample. Well, we only had one sample. We had a singular sample. So my explanation is a two sample Z interval for a difference in proportions is not appropriate because this is only a single random sample, and the two sample test requires two independent random samples. All right, so that's why it would not have been appropriate, and it really didn't take a whole lot of words to take care of that. So, all right, so this is 2007 question 5. This is another problem that's heavy on conditions. And we have researchers wanted to determine whether drivers are significantly more distracted while driving when using a cell phone than when talking to a passenger in the car. In a study involving 48 people, 24 were randomly assigned to drive in a driving simulator while using a cell phone. The remaining 24 were assigned to drive in a driving simulator while talking to a passenger in the simulator. Part of the driving simulation for both groups involved asking drivers to exit the freeway at a particular exit. In the study, 7 of the 24 cell phone users missed the exit, while 2 of the 24 talking to a passenger missed the exit. Would this study be classified as an experiment or observational study? Provide an explanation. The answer, this would be an experiment, and the reason why is treatments were assigned. Notice they use a simulator, so you could have done this. Obviously, if I just went out and observed people on the road, I couldn't have done that for ethical reasons. But here we assigned them to do this on a simulator, and so in this case, this is an experiment. So one group of drivers was assigned to talk on a cell phone, while the other group of drivers was assigned to talk to a passenger. So you need to give the definition, treatments were assigned, and then you need to explain how that was done, all right, or what those treatments were as verification. So state the null and alternative hypothesis of interest to the researchers in this test. Well, since I state the null and alternative hypothesis, I need to also define my variables. So make sure you do both of those. It's really easy to sit there and go, hey, I'm just going to state my null and alternative, but you have to go ahead and define your variables if they ask for that. So in this case, I said P1 equals P2, and P1 is greater than P2, and the reason I use greater because that's what they asked for in the question. So P1, the true population proportion of drivers who miss their freeway exit talking on a cell phone. P2 is the true population proportion of drivers who miss the freeway exit talking to a passenger. So both of these are talking. Both of these are talking, but one's to a cell phone and one's to a passenger. So one test of significance that you might consider using to answer the researcher's question is a two-sample Z-test. State the conditions required for this test to be appropriate, then comment on whether each condition is met. All right, the first condition, there must be 2 independent random samples or randomly assigned treatments. In this case, this condition is met as there are 2 randomly assigned treatments, so we're good to go there. All right, so we have 2 samples. Another one that is not here is N is less than 10%. If you're running an experiment and treatments are assigned, if you're running an experiment, which means treatments are assigned, you do not have to do N is less than 10%. All right, we don't have to do the N is less than 10% if we're running an experiment. So in this case, if you do, it's not a problem, but you don't have, it's not required. All right. So the next one is our sample large enough? Well, both samples must be large enough to use a normal approximation, and it has to meet all 4. In this case, N1 P1 has to be greater than 10, and N2 P2 greater than 10, etc. This condition is not met because the number of people who were talking on the phone was 7, which is less than 10, and the number of people who were who missed the exit while talking to a passenger was 2. So we actually have 2 sections that missed, But if you have one of the four that does not meet the criteria, we can't run the test. All right, so that one we couldn't do. We could not have done a test using that our methodology. So now they could go, okay, using advanced statistical method for small samples, and you're like, I didn't learn this, and you're right, you didn't. But they said, hey, we did this, we know more than you. We ran this test, and we got a p-value of 0.0683. Interpret in everyday language what this p-value measures in the context of the study, and what conclusions should be made based on this p-value. I'm going to tell you this. They were very nice and said they wanted it in context, they wanted it in everyday language, and they also wanted a conclusion. They could have just said interpret the p-value, and if they'd done that, they would still want all of those things. So make sure that whenever you interpret a p-value, you provide in context, in everyday language, and a conclusion. So here we go. Our first part, the p-value is the probability that we would get a test statistic as extreme or more extreme given that the null is true. That's a definition. That's not really, that's not definitely not in context, and it's not really in everyday language. But I'm going to satisfy, and I always like to start with the definition because it lets the reader know I know something. Now I'm going to put it in context and in everyday language. In this case, there is a 6.83% chance that we would get a test statistic this extreme, indicating that talking on the cell phone is significantly more distracting than talking with a passenger, when in fact there is no difference. Great. Taking care of context and interpreting it, but now I haven't drawn a conclusion. If they're asking for a conclusion, they're going, hey, basically what would be the end part of a hypothesis test? And here we go. The p-value of 0.0683 is greater than alpha of 0.05, so we fail to reject the null. Now our conclusion statement. We fail to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that drivers are more distracted talking on a cell phone than when talking with a passenger. Simplified, we cannot say that drivers are more distracted talking on the cell phone. So problem 11, 2003, question 2. This is one we've done before. Most of these you've seen before because they're good problems. When a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's monetary settlement. That settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against the manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it's convinced that more than 5% of the cars of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought this car and ask them if they experienced this defect in their cars. Define the parameter of interest and state the null and alternative hypothesis that the law firm should test. Once again, they were really nice to you. They told you to define the parameter of interest. They could have just said state the null and alternative, and you still would have had to define the parameter of interest. All right? So if they just said state the null and alternative, you still have to define the parameter of interest. Have to do that. So my null is that the defects equal 5%. My alternative is that it's greater than 5%. The law firm wants to know, hey, is this going to be more than 5%? So P naught is the true population proportion of cars of a given model that have a particular defect. In the context of this situation, describe type 1 and 2 errors and describe the consequences. I'm going to tell you, they don't need to tell me context and they don't need to tell me describe. I should do that automatically. So if they say describe a type 1 and type 2 error, or what is a type 1, type 2 error, always put it in context and always give the consequence. Once again, I like to start off with the definition. Doesn't have to be exact, but it needs to cover it. Type 1 error is the probability of rejecting a true null. Okay? In this case, a type 1 error would be for the law firm to believe that the percentage of defects was greater than 5% when in fact that it was not the case. All right, so that means I would have rejected this and I would have believed this when that wasn't the case. The consequence of a type 1 error is that the law firm would take the case but would not be able to cover its expenses. A type 2 error is the probability of failing to reject a false null. All right, and once again, people struggle with type 2, and I just always want to go type 2, fail to reject. Don't know if that helps, but type 2, fail to reject. It's probably failing to reject a false null. In this case, a type 2 error would be for the law firm not to believe that the percentage of defects was more than 5%, when in fact the percentage of defects was greater than 5%. So they believed that they didn't believe that it was greater than 5 when in fact it was. The consequence of a type 2 error is that the law firm will not take a case that had the potential of making the firm lots of money. All right. All right, problem 12, 2000, and this is 2013, question number 5. This is the longest problem of the day. So psychologists interested in the relationship between meditation and health conducted a study with a random sample of 28 men who lived in a large retirement community. Of the men in the sample, 11 reported that they participate in daily meditation, and 17 reported they do not participate in daily meditation. The researchers wanted to perform a hypothesis test, and what they wanted to know was, is the proportion of meditation minus the proportion of those who don't practice meditation, do they have a different amount of high blood pressure among them? So where PM is the proportion of men with high blood pressure among all the men in the retirement community who participate in daily meditation, and PC is the proportion of men with high blood pressure among all the men in the retirement center who do not participate in daily meditation. And I'm saying, I suspect that they use the C for like control, because they're not taking the treatment, although these treatments were not assigned. If the study were to provide significant evidence, null HO in favor of HA against the null in favor of the alternative, would it be reasonable for the psychologist to conclude that daily meditation causes a reduction in blood pressure for men in the retirement community? Explain why or why not. So basically, if you ran the study, you had significant evidence that said meditation reduces blood pressure, can we make that statement? And the answer is no, we can't, because this was not an experiment. This was an observation. Treatments were not assigned, so this is an observational study, and no cause and effect relationship should be drawn. All right? So we couldn't make the statement even if it had been statistically significant. If it had been statistically significant, we could say, hey, there's a relationship or there's an association, but we could not make that causative statement. All right? The psychologists found that 11 men in the study who participate in daily meditation, 0 had high blood pressure. Wow. So of the 11, 0 had high blood pressure. Of the 17 who did not participate in daily meditation, 8 had high blood pressure. So essentially, I'm just going to write this up. We had 0 over 11, and we had 8 out of 17. Okay, and this is my meditation group. This is my those that did not participate. I'm doing this now because we're going to refer to that later. So let P hat M represent the proportion of men with high blood pressure among those in a random sample of 11 who participate in a daily, who meditate daily, and let P hat C represent the high proportion of men with high blood pressure among those in a random sample of 17 who do not meditate daily. Why is it not reasonable to use a normal approximation for the sampling distribution? All right. Sample size. Both samples must be large enough to use the normal approximation. For this to be a case, all 4 must be met, and in this case, they're not. We have 0, which is less than 10. We meet it here, but then we have 8 with high blood pressure, which is less than 10, and this number, and I should have shown where it came from, was a 17 minus 8 equals 9. So we had 9 for the other part. So basically, the condition is not met because not all 4 were greater than 10. In fact, 3 out of the 4 were not greater than 10. But if any one were not greater, we could not have proceeded. All right, so that's why that wasn't possible. Okay, this is where we're going to get a little tricky on this problem, which is why I wanted to show this, the simulation part. Although a normal approximation cannot be used, it is possible to simulate the distribution of this under the assumption that the null hypothesis is true. 10,000 values of p hat m minus p hat c were simulated. And they keep giving me this, and that's actually really important. That's my clue. We're simulated, and the histogram shows the results in the simulation. So what they're saying is this simulation right here shows the proportion of who meditate minus the proportion who do not meditate, and it's a high blood pressure who meditate minus high blood pressure who don't meditate. So that's what's shown here, okay? That's what they've shown. And so basically here we have these list of numbers. Sometimes it's negative, but it also moves to positive. And we're basically showing, once again, the proportion of people who meditate and have high blood pressure minus the proportion of people who do not meditate and have high blood pressure. So based on the results in the simulation, what can be concluded about the result between blood pressure and meditation among men in the retirement center? Well, I know 0 out of 11, because 0 had high blood pressure who meditated. 0 out of 11 is 0. 8 out of 17 is 0.47. And I know that I'm doing meditation minus this, so this is 0 minus 0.47, and that equals negative 0.47. Well, that's right there. So this is what they're saying, hey, we want to know what that is. Well, it happened how many times? It happened 76 times out of 10,000. So 0.0076. So what could be concluded in this case? In this case, our p-value would be 0.0076 based on the simulation. There is a less than 1% chance of getting a test statistic this extreme or more extreme in favor of those who meditate having lower blood pressure than those who don't, given the null of no difference is true. So I could state it this way, but I needed to make sure that I define my p-value. And you could have just said p-value is this, it's less than alpha, we would reject. And then we state our p-value is 0.0076. We reject the claim of no difference in blood pressure. There is sufficient evidence at alpha equal to 0.05 to suggest that there is a relationship between meditation and low blood pressure. While the results are statistically significant, this is not an experiment and no cause-effect statement should be made. All right? Really important to say that make sure you make this key phrase, that there is a relationship. All right? Make sure a relationship or association. There is an association, there is a relationship, but there we can't say that it was causative. That, to me, is a fairly difficult problem. I would be surprised that we have the one like that this year. But once again, since we're trying to prepare, wanted to show as much as I possibly could. So I'm going to pause the recording.